The other part of DeMoivre's theorem is finding the roots of complex numbers. So this will remind you of what we did with dividing. The only difference is because there are multiple options in terms of getting square roots, cube roots, and so on, that there's multiple possible answers. We may have to do this multiple times. What is going to happen if you have a cube root? Notice it says 3 cube roots. Think about it. The index of a cube root is 3. If it was a square root, you'd find 2 square roots. Fourth root, you'd find 4. We're going to do one that's kind of in the middle because a fourth root would be a lot to do. So we're going to be finding 3. The formula looks a little crazy, but what we're going to be doing is working with coterminal angles, where square rooting, cube rooting, whatever the index is, and then dividing by that value. And we're going to do that multiple times by getting coterminal angles, so we can get the different options. So in this case, we have the fact that n is 3. Notice in the formula, we're going to go up to roots of n minus 1. So that's why I was saying we're going to be doing, notice there's a 2 here. What that means is we're going to be finding z0, z1, and z2. Those are going to be our 3 roots later on. You don't really need to write this stuff out. You just need to realize that you are going to be finding 3 of them. So just like we did before, we're going to convert this over into polar form. This is in quadrant 2. So we will do r equals square root of 2 squared plus 2 squared, which is the square root of 8. Which is the same as 2 square root 2. We're going to hold off on that because we're going to be doing something with that value. And then we have the fact that tangent theta is equal to 2 over negative 2. And that's going to give us theta of 135. I'm actually going to put this in degrees. You could do it in radians. It might be a little easier to do these in degrees. Now, if you notice in the formula, we are going to be doing the root of a root. So we're going to be doing the cube root of a square root. This is going to involve us converting over into rational exponents. That will help you with kind of simplifying this. So this is the same as 8 to the 1/2 to the 1/3. Now normally you would multiply those, but what I would actually recommend is switching them. Because when you're raising an exponent to an exponent, you could do it in a different order. So you could cube root and then square root. You might be thinking, how is that going to be helpful? Well, if I switch this, which you can do with multiplying because it's commutative, I can take the cube root of 8, which is 2, and now I've simplified that into just the square root of 2. That's a little tricky, but it's going to be helpful for later on when we are multiplying this stuff out. Okay. Now, zk, and I'm going to do all of these on the next page. I'm just going to write this here, so make sure you write this down. It's going to be the square root of 2 every time. And then it's going to be cosine of 135 plus 360k. So the first time around, since we're going to be doing the 0, we're not adding the 360. Divided by 3 because it is a cube root. Plus I sine of 135 plus 360k over 3. So all that means is we're going to do it 2 more times and add the 360 on and get our coterminal angles. So we're going to be finding, like I said before, z0, z1, and z2. And we're going to move on to the next page to do this. So make sure you have this copied down so you can refer back to it. Alright, so z0 is just going to be square root 2 times cosine 135 divided by 3 plus I sine 135 divided by 3. Now this comes out nicely, so if it comes out exact, we'll keep it exact, and if not, we will just round decimals. We'll get square root 2 times negative root 2 over 2 plus I square root 2 over 2. So it's going to be negative 2 over 2 plus 2 over 2i just comes out to negative 1 plus I for our first one. We're going to do the same thing again. And this does not come out exact, but that's okay. But now we're just going to add 360. So we'll do cosine 135 plus 360. So really, you're going to do this. You're going to keep adding the 360 until you get the amount of roots that the question is looking for. Since we get 165 when we divide in this case, and that's not something that we know an exact value for, we will just get an approximate. So negative 1.366 plus 0.366i. That's our second root. And now it said to find 3, so we're going to do z2. And if you think about it, the 1 just means add 360 once. And the 2 means add 360. Apparently I can't spell the word once. Let's fix that. And that just means add 360 twice. So root 2, cosine of 135 plus 360 times 2, still over 3, that does not change. Again, we're going to get an angle measurement that we don't know an exact value for, 285, so we will just calculate this. .366 minus 1.366i. So it's a lot of work, but it's the same process, just repeated over and over again, and it's similar to the dividing process that we did in the previous video.